Hello, everyone. Today we're going to solve the Leet code problem palindrome number. And so let's look at the description and see what it means. So given an integer x, so we're given this numeric, return true if x is a palindrome and false otherwise. So you might be asking, what is a palindrome? A palindrome is a value in which if you read it forward and you read it backwards, it's the same value. So it's not exclusive to numerics. You could also have it for strings, like the word mom, MOM. So you can imagine M-O-O-M. If I read it forwards, M-O-M, it's the same backwards, M-O-M. The same with the value 121. Notice the 121. If I read it forwards, 121. If I read it backwards, 121. Right. Now, if I have a negative value, notice that it's not going to be the same forwards and backwards just because the the negative sign is on the left to the left of the number. Whereas if we were to reverse it, we could see that it's no longer the same value. And the same thing with 10, right? So 1, 0 is not the same as 0, 1. So if we were to essentially reverse it, it reads a little bit differently. So in order to perform this, let's kind of brainstorm a little bit about what are some things we want. We take in an input, take an integer input, and then we just essentially, you could see from the test cases that negative values will get disqualified just because that negative sign is not symmetric. So that's something to consider. So negatives are disqualified or just false in general, right? So they're not palindrome candidates. Now the next test becomes, how can we read a number like 121 and make it so that we compare if it's the same forward as it is backwards? The way you can do this is you can iterate through the string, but only halfway through the string. So if it's odd, actually let's look at a larger version of this. So let's say, for example, I have the numbers 1, 2, 3, 4, 3, 2, 1. You can see that this is symmetric on both sides, 1, 2, 3, and then 3, 2, 1. 4 is in the center. So here we have an odd size. This is going to be 7, 7. So essentially, all we need to do is we just need to check the first 3 values and compare them against the last 3 values. But the way we're going to do this is we're going to set up 2 pointers similar to the last problem. So we're going to have a left index or a left pointer and a right pointer. And what we want is, once again, we want our left pointer to start at the beginning of the string and then our right pointer to start at the end of the string value. I know we take in an integer, but that's just a quick conversion with a 2-string function, and we can get this into a string version. The reason why is because it's going to be much easier to manipulate than if we had kept it as a numeric. We could do this same logic with the numeric, but it's going to take a little bit more work. So it's simpler if we just convert the integer to a string. Right, so what we do is we start off at the tail ends and we compare, are these 2 values the same? Yes, they are. So then what we do is we increment the left pointer and we decrement the right pointer. And now we check these values. Are these 2 values the same? Yes. So then we can continue to the next values, this 3, and then also this 3 right here. Are these 2 the same, or do they have the same value as elements? Yes, 3 and 3, that looks good. Notice I don't have to check the 4 though, because if it's odd, the 4 is right in the middle, so it's a symmetric point. So it's going to be the same on both sides because it's right in the middle. And so what's another way of saying that? In this instance, for size 7, we only had to check the first 3. The way we do that is we could say we only check indices that are less than the size divided by 2. So let's see what this means. So this should be less than index 3, right? So this is index 3. So I should only be checking index 0, index 1, index 2. Does this hold? Does this value give us 3? Well, if I have 7 and I divide it by 2, according to integer division, right? So 7 divided by 2 without any decimal point, it becomes 3. I know sometimes we have the tendency to make that double, right? The 3.5, but that's not the case here because we're having a whole number divided by a whole number, or an integer divided by an integer. So our result will be an integer. So that's why if we do 7 divided by 2, we're really getting 3. Right? That's just the programming kind of like implicit cast of it, or not implicit cast of it, but that's the integer division, I should say. So this works for as we can see for odd cases. I just want to prove to you that this also works for even cases. Say, for example, if I were to do 1, 2, 3, 4, and actually just 3, 2, 1. There we go. So here's 6 values, size 6, size equals 6. And here we're only going to check the same condition, less than size divided by 2. So this is going to be the same as less than 3. Let's see if that holds true. So less than 3 means only indices 0, 1, and 2. So this is indices 0, this is indices 1, this is indices 2. Perfect. So we're only performing 3 iterations. The same here, we're only performing 3 iterations. I do recommend kind of practicing these boundary conditions on your own and proving it to yourself, just because it doesn't sound like it would work for both odd and even cases, but then once you kind of trace the loop, you'll see that it does work. So now that's really the most difficult part of it. That's really all we need to do. We know we have our left and right pointers. We know we disqualified negatives, right? We're going to do comparisons. If at any point the comparison fails, like let's say this was a 7, and I compare the left pointer and the right pointer and they're not matching, then at that point it's disqualified and I know I can return false. But if I'm able to go through all the 3 comparisons in this case and they all match, so let me return this back to a 1. If I'm able to perform all the comparisons and they do match, then I can return true. I know it is a palindrome. So what we're going to do is let's go ahead and disqualify the negative values. So if x is less than 0, right, so negative values, then what we want to do is just return false, right? Because we don't want to have to deal with the rest of the computations if it's already a negative value. The next thing we want to do is we want to take a string. Actually, next thing we want to do is we want to include string before we use it. So we want to create a string, and we want a string version of this integer. So there's already a method that exists for creating that. I'm pretty sure we might be able to use like a constructor, but there's the toString function that exists to do that. So here's my my string version of the integer. And that's going to be toString, and I need to provide it the input. So this just converts integer to string 12. That's pretty much it. So it converts the 121 to 121. That's pretty much it. Now that we have that, we just need to iterate through the string. Let's see. So we're going to set up our for loop. We're going to have int. We're going to set up two pointers. The first one is the left pointer, which starts at the beginning. We also have our right pointer, which will be initialized at the very end. So we know that the end is going to be our size minus 1, right? That's the last index. So here we have our left pointers and right pointers set up. They're not referring to the elements, but they're just the indices. What's our boundary conditions? How often, when do we want to continue these comparisons? Remember, it's going to be less than the size divided by 2. So we're going to say, while the left pointer is less than the size divided by 2, and out of kind of for readability sake and also out of abundance of caution, I'll just go ahead and put that in its own parentheses. And then we'll go ahead and increment the left pointer every time because we want the left pointer to move forward, and we want to decrement the right pointer. There we go. And just like that, we set up our for loop. So we have our left pointer, right pointer set up. Left pointer will increment, right pointer will decrement. Let's do the comparisons. So we want to check if the left value, let's set up values for this. So here it's going to be the char left value, because since we're only going to take a single letter from the string, so a single character from the string, or a single element from the string, the elements of a string are characters, so that's why I'm just setting that to character. The left value is equal to the stir version at the left pointer, and the right value is equal to this the character at the right pointer position. So if the left value is not equal to the right value, then that's when we know that it wasn't a palindrome because it didn't match. So we could always return false in that instance. Now, it's going to continue this loop for all the iterations. So this is the meat and potatoes. It's going to check all the way until it goes through all the valid test cases. So for example, it's going to check these three against these three against these three in sequential order. If it's complete and I never triggered the a difference, then I know that at the end of the function, I can just return true. And that's it, right? So that's how we can check if it's a palindrome. Let's go ahead and run it, see if I didn't make any syntax errors. Let's see, so on line 28, to notice to match this solution. That's one thing I've never been a fan of. I've never been a fan of when these have been placed on here. Actually, I like kind of like the brackets here. Oh, there we go. Okay, looks good. Let's go ahead and just fix that error. I think I was just missing the brace. There we go. So this looks good. Sorry about that. That's pretty much it. This is going to be the same format on how to pretty much also reverse a string, this kind of same idea. It's very common to kind of have left and right pointers for different types of coding problems. I hope that this made sense though. Please let me know if you had any questions, or let me know if you found this pretty easy or a little bit difficult. I thought it was kind of a nice, smooth sailing problem. But thank you so much for watching. I hope you enjoyed. And please like, share, and subscribe if you enjoyed, and I hope to see you soon.